Hey guys, we're talking about graphing quadratics today in standard and vertex form. We're going to take what we learned last video and apply it to the graphing. For the first equation, first of all, actually, this assignment's going to be due Wednesday, the 22nd, 11:30 p.m. Okay, we're going to sketch the graph now and make sure that we use 5 points to graph. Okay, first we've got to find the AOS. And of course, the AOS is negative b over 2a. So negative b, which would be negative negative 2, positive 2 over 2a. So that is 1. Plug it back in to find the vertex. Vertex is 1 squared is 1, minus 2 times 1 is 2, minus 3. Again, remember my opposite and doubled. 1 minus 2, negative 1, minus 3. Negative 4. So therefore my vertex is 1, negative 4. All right, I'm going to plot my vertex. 1, negative 4. There it is. And of course, the second we plot the vertex, what are we going to do? We're going to draw the axis of symmetry. Okay. After we find that, let's see. Axis, vertex, minimum, maximum value, it's going up, so it's a min. And the min value, remember, y by the vertex, so that's negative 4. Now we're going to draw an xy table. Remember, we need 5 points to graph. So we already have our vertex, 1, negative 4. Our y-intercept, remember, this is our y-intercept. So our y-intercept is 0, negative 3. 0, negative 3. Let's plot that. Okay. We need a third point. Our third point is going to be, let's see, 1, 0. What comes next? Negative 1. That's our third point. So let's plug it in. Negative 1 squared is 1. Negative 1 times negative 2 is positive 2 minus 3. 3 minus 3 is 0. Negative 1, 0 is right here. And now we're going to reflect. 1, 2, 1, 2. 1 and 1. And here we are. Here are our 5 points on our parabola. There we go. Notice this hits our x-axis 2 times, which means it has 2 solutions. Remember that, guys? 2 solutions. You're going to see on a couple of the Sophia problems, it's going to ask for the x-intercepts. So the x-intercepts here are, what does that say, negative 1 and positive 3. X-intercepts, negative 1 and positive 3. Okay? All right, last thing we need to find is set and interval notation. Okay, so the domain, we'll still see that, yes we can. Domain is all real numbers. That's set, interval, negative infinity, positive infinity. And then the range, y is such that y is, because it's going up, greater than or equal to y by the vertex, negative 4, and then negative 4 comma infinity. Okay, next, let's go to number 2. Okay, negative b over 2a. Negative b, so that's 4 over 2 times negative 1, negative 2. Plug it back in. Remember, for the vertex, when you plug it back in, that's negative 2 squared is 4 times negative 1 is negative 4. As a matter of fact, I'm going to show the work there. PEMDAS. 4 times negative 2 minus 5. So, so that's 4 times negative 1 is negative 4 plus 8 minus 5. That's 4 minus 5, negative 1. So there's my vertex of negative 2, negative 1. And the second we plot that, we draw our lovely axis of symmetry. It's really uneven, sorry. And let's see, it's going down, so it's a max. The max value is y equals y by the vertex, -1. Draw our xy table. We have vertex, -2, -1. Our y-intercept, 0, -5. Okay. All right. So now, what do I have left? I need a third point. What's missing? I have a -2, I have a 0. Hey, let's put what's in between. -1, that's my third point. Plug it in. -1 squared is 1 times -1 is -1. -1 times -4 is +4 minus 5. That's 3 minus 5 is -2. So -1, -2. Notice it's going down and reflect. There you go. Okay. Notice this has no x-intercepts. This has 0 solutions because it doesn't hit the x-axis at all. Whereas on the first problem, this has 2 solutions. Okay, this is an example of no solutions. Okay, and then we can do our domain and range. Matter of fact, I'll put it up here. Hopefully we can see this. The domain we know is all real numbers. Set notation, interval notation, and then our range. Y such that y is, it's going down, so it's less than or equal to y by the vertex, -1. And then interval is -∞, comma, -1. Remember, with -∞, it goes -∞ up to -1 when it's going down. Third problem. Okie dokie. (b over 2a). So we have (b), which would be -16 over 2 times -4. -16 over -8, +2. Plug it back in for my vertex. -4 times 2 squared plus 16 times 2 minus 12. So that is 4 times -4, -16 plus 32 minus 12. That's 16 minus 12 is 4. My vertex, 2, 4. Plot it, 2, 4. Here we go. The second I plot it, you highlight the axis of symmetry. All right. And it's going down, so it's a max. And the max value is y equals y by the vertex, 4. All right, next, xy table. 2, 4. That's my vertex. And my y-intercept is 0, -12, which would be right here. Okay, so what am I missing? I'm missing a 1. Now, normally, no, actually I would say 1, excuse me. Okay, so if you notice it's going by 2's here, so 1's going to be here. So 1, plug it in. -4 times 1 is -4. 16 times 1 is 16 minus 12. -4 plus 16 is 12 minus 12 is 0. -1, 0. So here, okay, this will be my third point. See how it's going by 2's here and reflect. Okay. Notice this is a skinny graph. Remember, fractions are fat. So therefore, this is a 4. Notice that's a skinny graph. All right, and what's left is my domain and range. Domain, all real numbers. Set and interval. And my range, y such that y is, it's going down, so less than or equal to y by the vertex, 4. And then -∞, comma, 4. And there we have our 3 problems in standard form. Okay, our next 3 problems are going to be in vertex form. Okay, vertex form. If you remember, for vertex form, we have opposite and as is. Remember. Okay, first of all, let me write vertex form up here. Y equals a x minus h squared plus k. We have to take the opposite. This is as is. Hopefully you remember that by now. All right, first problem. Axis of symmetry is, taking the opposite is, -2. Vertex, -2, 3. Minimum, because it's going up. Remember, this determines up or down, and it's positive, so it's a minimum going up. And the minimum value, y by the vertex, which is 3. All right, let's make our xy table. Okay, my vertex, -2, 3. Y-intercept. Now remember, the y-intercept is not 3. We have to plug in for the y-intercept, let x be 0. To find the y-intercept, let x equal 0 and solve. 0 plus 2 is 2. 2 squared is 4. 4 plus 3 is 7. Okay, again. 0 plus 2 squared plus 3. 2 squared is 4 plus 3 is 7. All right, so -2, 3. Oh, I didn't graph this yet, that would help. -2, 3. Second, I plot it. Draw the axis of symmetry. 0, 7. Okay, what's missing? I got a -2 and a -2 and 0. So what's missing? -1. Plug in -1. -1 plus 2 squared plus 3. -1 plus 2 is 1. 1 squared is 1. And 1 plus 3 is 4. -1, 4. And reflect. Here's my parabola. Can you see that all? Sorry. Okay, and again, the domain, I'm just going to write the domain here for both of them because we know the domain is all real numbers. -infinity, +infinity. Okay, that goes for both. And then the range, y such that y is greater than or equal to y by the vertex, which is 3. And then 3, infinity. All right, next. Okay, axis of symmetry is 1, taking the opposite. Vertex, 1, -3. All right, this is going down, so it's a max, and it's y equals -3. Let's make an xy table. Okay, before we do that, 1, -3. 1, -3. Okay, second I plot it. That's the symmetry. Okay, 1, -3, and let's plug in 0. 0 minus 1 squared minus 3, and solve. 0 minus 1, -1. -1 squared, 1. 1 times -2, -2, minus 3, -5. Okay, what's my third point going to be? I have a 1, I have a 0. Third point, -1. Plug in. That's -2 squared is 4. Times -2, -8. Minus 3, -11. -1, -11. There's my points. Reflect. there's my parabola. Okay, we said the domain was all real numbers, like we said, and now it's just our range. Our range, we'll put that right here. Y such that y is going down, so it's less than or equal to y value of the vertex, -3. So therefore it's -infinity, comma, -3. And the last one. We have a fraction. Oh no. By the way, 4 and 5 both have no solutions because they are not touching the the x-axis. Okay, last problem. AOS is opposite 2. Vertex 2, 3. 2 and 3. Okay, we know it's pointing up. So it's a minimum, and the minimum value is 3. Okay, let's do an XY table. We have 2, 3 as our vertex. Let's plug in 0 for our y-intercept. Now, 0 minus 2 squared plus 3. 0 minus 2, -2. Squared is 4. Half of 4 is 2, plus 3 is 5. 0, 5. Okay, now, I have a 0 and a 2. Now, normally I would say -2. I could do -2, but it'll probably go off the graph. So they really wanted me to do a 1 here. Okay, not the worst thing, we can deal. 1 minus 2 squared plus 3. 1 minus 2 is -1. -1 squared is 1. Half of 1 is a half. 1/2 plus 3 is 3 1/2. So that's 1 and 3 1/2. And reflect. One, two, 1, 2. Notice a half is fat, okay? We know the domain is all real numbers. -infinity, +infinity. And the range, y is such that y is, it's going up, so it's greater than or equal to y value of the vertex, which is 3. And it's 3 infinity. And there we have it. We have graphs going from graphing in standard form and graphing in vertex form. Okay, again, your assignment is due on Sophia on Wednesday.